Okay, guys, we are entering into the second and the last part of the this lesson on the mean. Now we have to see that how to find the mean, how to solve problems on mean when we have coded data. Okay. Now this coded data thing really, I mean, annoys the students. Look at this. This is a kind of very scary kind of notation here. You see the sigma x plus 2, sigma x minus 1. Look at these questions, okay? So these will be bothering you, these notations, okay? If I show you here, even in the examples, okay? So now let me tell you, what is this coded data? Once you understand this thoroughly, then inshallah, there will be no problem in solving problems related to the coded data. So let's discuss that what is this coded data. Guys, the mathematicians they're really very clever people. They always find out ways to minimize the working, to minimize the time to solve a certain problem. Now suppose you have to find the mean of let's say there is 242, 246, 238, and let's say you have 245 and 235. Okay, now these are the values that you have to find the median, I mean, sorry, you want to calculate the mean. These are the values of your x. Now how we code this data, rather than finding the mean of all these values. Now let me give you an easier example first, and then I'll take you back to this difficult one. Now suppose, guys, you have let's say you have 10, 12, and let's say 4. I'll be taking a very easy example. Okay, now these are the three observations. We want to find their mean, and we want to find the mean without making much of the calculations. Okay, you will assume a mean over here. This method of coded data is also known as the assumed mean method. This is also called, now your syllabus uses the word coded data. Assumed, when we studied this, it was called assumed mean method. Okay, this is called assumed, but your syllabus says this is the coded data thing. Okay, now we just assume that there is a mean which is, let's say, 10. Okay, so we find the deviations, a new data, deviations. This will help you to learn the formula on standard deviation. We take out 10 from all these values. We get 0, 2, and 4. So we have used a formula that these deviations are x minus a. You can easily find the mean deviation or the mean of these new values. You know that this is 0 plus 2 plus 4 is 6. 6 over 3 is going to be 2. So the new mean is 2. Okay. The actual mean would be 2 plus 10, which is 12. Look at this. What is the mean of 10, 12, and 14? If you add all of them, you get 36. And 36, this 36 divided by 3, you get 12. Okay. So isn't it cool that you take out 10 from all these values, okay, just to make it smaller numbers, lighter numbers, and you find the mean of these new numbers, and then you add this 10 back into this new mean, okay? You get the original mean, which is going to be 12. Now, look at this example here. I'm not going to find the mean over here, but I would assume that my mean over here is, let's say I take my A as 240. Okay. Now my deviations, which are going to be x minus A, I'll take out A from all these values. Okay. So 242 minus 240 is 2. 246 minus 240 is 6. 238 minus 240 is minus 2. 245 minus this is going to be 5. and then 235 minus, this is going to be minus 5. Okay, so we have been very clever over here. You see the sigma d is going to be just 6. Okay, and what is the new mean? That is going to be 6 over 5, and I get 1.2. Guys, see how quickly I can determine the new mean. I mean, the actual mean. That would be 240 plus 1.2. That is going to be 241.2. I did not have to add all these bigger numbers. Okay, I just used the new data, found the mean, and found the mean, and then I added this 240 back into this 1.2, and I got the actual mean. What do you say, beta? Isn't it a cool method? Hmm? Yes, macho.
Yes, sir.
Acha.
Yes, sir.
So you just remember this is d is equal to x minus a, and from this you can put the mean sign on that this d is the mean of d is going to be the mean of x minus a, and from this you can say that the actual mean is the you can call this mean deviation, okay, plus this a. That is how you will get this original mean. And believe you me, this also works on the frequency distributions and on the group frequency distributions even. Now let me take an example of the frequency distribution over here, okay? Now suppose we have a data. Let's take the example of my hands again, if my hands don't mind it. Okay, now we have x. Let me change this color. We have x, okay, and we have this f. Now suppose there is, I became a big farmer, and I have many hands with me, and now the eggs per day I'm getting, inshallah. You know, these days I started with 10 chicks, okay, and do you know how many hens now I have? Guess. I started this in March. Hmm? March of this year. Hmm? Any wild guess? How many hens do I have now?
8.
Anyone? Hmm?
8, sir.
12.
Very close. I have 18
12?
hens. 18.
Oh, wow.
Okay.
MashaAllah,
Okay.
sir.
Acha. Now, guys, look at this. Now, suppose I'm getting let's say I'm getting 355 eggs on 5 different days, then 360 eggs on 10 days, then let's say 362 eggs on, let's say, 12 days, and 365 days, sorry, eggs on 8 days, okay? I want to find the average number of eggs over these particular days, okay? This duration. I want to make my calculation easier here, okay? So I would say, okay, let me keep my A as 360. This is totally up to you. You can keep any number. There's no rule to fix this A, okay? So you can just suppose this to be any number, okay? So if my A is this 360, my deviations would be x minus 360. So I'll have a column here for these deviations, okay? Now 355 minus 360 is minus 5. This one is 0. This one is going to be 2. And this one is going to be 5, okay? My next column would be FD, okay? So this is, I'll be multiplying these two columns together. I am not going to use this anymore, okay? This is 5 into minus 5 is minus 25. This is 0, this is 24, and this is 40. And I have to see that how many days I have been collecting these eggs. This is 15 plus 20, that is going to be 35, okay? We add this is going to give us the new number of eggs here. This is minus 1, this is going to be 39. This is 39, okay? So now the mean deviation is going to be sigma FD over sigma F. So this is going to be 39 over 35. That is, can you please tell me through the calculator, this is 1 point, a very small number, 4 over 35, 1.0 something. What is this? Yeah,
Sir,
please
it's
tell me.
1.11.
1.11.
Okay, thank you. God bless you. 1.11. So what is the original mean, bacho? That is
361.11.
1.11, okay? Or if I want to keep this correct to three significant figures, that is going to be 361. So remember the rule that you have to suppose a number yourself, okay? And you see that this sigma FD is basically sigma. You might see in your questions in your exams that the sigma F into X minus 360. You might see like this is there is sigma X plus 2. Look at this. You're seeing this thing over here, okay? Sigma X minus 1. So this means for this question, your A is 1. You will find the mean and you will add 1 into it. You will get the original mean. You will find the mean. This data has been increased by 2. Okay. So you will take out 2 from that mean. So you will be getting the original mean. Okay, guys. So the rules that you will be applying over here, these will be that your D is going to be X minus A, and your mean would be then the mean of these deviations, and you put that A back. Here you're taking out A from X, you're putting this A back into the mean so that you can get to the this original mean over here. So remember these two formulas, okay? And this also works in the frequency distribution. If it works in the frequency distribution, then obviously this can work in the group frequency distribution as well. Now let's have a look at the questions. And if you think there can be a question that can put you in trouble here, before I take to the questions, you must, I've seen there's some very good examples here. Okay, look at this example here. It says that the exact age of an individual boy is denoted by B. Okay, fine. And the exact age of an individual girl is denoted by G. Exactly 5 years ago, the sum of ages of 10 boys were this. Okay, the sum of this. So sigma B minus 5 is going to be 127.0. Why did he write sigma B minus 5? Hmm? Yes?
Sir, because अगर एक individual की B है, तो 5 years ago it would have been B minus 5, and when you add all of
So
the ages
exactly.
from
All
5 years ago, then
yeah, we have to go 5 years back. So that is why there's B minus. That means each individual's age is going to be going 5 years back. Okay. In exactly 5 years time, the sum of the ages of 15 girls will be this. So you see that now he's talking about the future. So you have sigma G plus 5. Okay. Find the mean age today of the 10 boys. So he's going to find all of this, okay? And you see that he has added 5 into it. Can you see that? He has added 5 into it. Okay, guys, if I change the sigma B minus, I talk to myself and I say, okay, the sigma B minus 5 is basically sigma D. That is a deviation, okay? So you find the mean deviation, that is sigma D over N, which is 10 over here. So we are given the sigma D, which is 127. This is 127 over 10. That is going to be 12.7. So now what is the actual age? So that is the mean of the B. So that would be 12.7 plus, if there is a minus over here, you need to put that back into this mean. So that would be 17.7. Okay. In case of girls, you see that there is an addition going on here. Okay. So to so you look at this, he has found this, and then he has subtracted 5 from this. Can you see that? Here, this was being added, and here it is being subtracted for these 15 girls. ठीक है बच्चों? Then he says the 10 boys and 15 girls combined. So you have, this is the current average of the boys. This is the current average of these girls over here, है ना? ये जो हमारे पास, where is the average? Yeah, this is the current average of these girls. So if you want to find the average, have I told you about how to find the combined average? Hmm? Guys, do you know how to do this? बच्चों बोलो यार जल्दी से हाँ ना बताओ ना यार. Can you do this? 10
So
boys
we'll
and
just add the averages
oh,
of
this is a very common
over
mistake.
25.
Let me tell you from my own example, and then you can try this yourself. Okay. Suppose uh, I have the hens. Okay, and my hens are giving me, let's say, 5 eggs per day. Okay. And this has been for, let's say, last 10 days. Okay. And there is another, like, aap mein se koi bacha, you also keep the hens. Okay. You are a farmer. So you have collected the average you have is 7 eggs per day. Okay. But the number is different. This is going to be for, let's say, for 12 days. Some of you are saying that you find the average of the averages. The average of the averages, in what case this would work? चले आपसे पूछता हूँ. In what case, if we want to find the collective average, so how can that be the average of these averages? What is the condition there? Hmm?
Sir, if n is the same?
Exactly, beta. God bless you. N has to be the same. Then total number, both of these data, they should have the same N. Okay. But in this case, the N is different. Okay. So to find the combined average, you should have the combined sum. Okay. This is my own version of the formula. You can note it down. The combined average is going to be the combined sum over the combined frequency or the combined number. Okay. So what is the sum here? What is sigma x here? If you remember the formula that the mean is sigma x over n. So if you cross
Sir,
multiply,
5 into 10?
yeah,
So
that
is
would
it
be, yeah,
12?
that is going to be 50. And here the sigma x is going to be 12 into 7. So that is 84. Let me call that y, the combined sum, okay? The combined sum is going to be 50 plus 84. That is going to be 134. The combined n is going to be this 10 plus 12. That is 22. So the combined average would be 134 over 22. That is how you will find this combined average. Let me ask you a question on this. Suppose there is a character, okay, and this character has, suppose, let's, my favorite was Inzamamul Haq, okay, I'm just going to talk about Inzamamul Haq. Now, suppose Inzamam has played, let's say, 100 matches. Oh, this color is okay. Suppose Inzamam played 100 matches inside Pakistan. Okay. And his average in those 100 matches is, I have just distracted from the actual topic, which was the coded data, but just because this is something that you must have done in your O levels. Now, suppose his average inside the country is, I'm just going to take a round value 50. Okay. And he has played 50 matches outside the country. I'm just supposing, okay, these are not the actual figures, okay? And his average outside the country is, let's say, 70. And we want to see that what is his overall average in 150 matches altogether. Bacho, how would you find that? The overall average. The average in these 150 matches. Yes. Hmm? Yes. यार मैं वेट कर रहा हूँ मेरी रिकॉर्डिंग हो रही है यार ऑन एयर जा रहे हैं हम लोग बताइए जी
Sir, 50 times 100 plus 50 times 70.
Yeah, if you want to find the average in these 150
Over
matches,
150.
yeah, if you want to find the average of these 150 matches, obviously you need to know that what is the total score in all his life, okay? So inside the country, if we multiply them, we get 50 times 100, okay? That is the score he got inside the country, he made into the country. And this is the score he's making outside the country. And altogether, he has played 150 matches. So this would give you his overall average, okay? So I'm going to go back, Bacho, to the this coded data thing. Though I have explained you this thing, but this will be more clear to you when we will be solving the past paper questions on this coded data, okay? Right now, if I can take you back towards the this exercise over here, um, I don't see very good questions over here. So guys, I'll be taking questions from the past paper, maybe tomorrow, inshallah. I'll cover this. First of all, I'll tell you how to find the median and the standard deviation, and then I will be taking you to the past paper questions. Okay? Okay, guys?
Okay, sir.
Okay.